got energy, you got power, you have everything. I've invented a device that extracts electromagnetic energy from all around us and transfers it into electrical.
Imagine a place where particles collide at near light speed, recreating moments after the Big Bang and sparking claims of portals to other dimensions. Is the world's most advanced physics experiment truly opening doors to the unknown? Or are these ideas fueled by viral rumors? A 13-year-old prodigy recently challenged these claims with insights that unsettled even experts. So what's really happening beneath CERN's tunnels? And where does real science end and speculation begin? The CERN Collider and portal rumors. Deep beneath the France-Switzerland border lies a massive scientific instrument known as the Large Hadron Collider. This 27-kilometer circular tunnel is home to some of the most powerful machines ever built. Inside, beams of protons race close to the speed of light before crashing into each other in precise collision points. The goal is to recreate the conditions that existed just moments after the Big Bang and unlock new secrets about the universe's fundamental particles. Despite its scientific purpose, the collider has attracted rumors that it might have done something far stranger. Stories have circulated online claiming that these high-energy collisions have torn open a portal to another dimension. The rumor paints a picture of hidden gateways under the Swiss countryside, where mysterious energies escape and possibly threaten reality itself. This idea has captivated public imagination, mixing fascination with fear. These claims, however, remain unconfirmed and exist mainly in the world of speculation and sensationalism. No official CERN documentation supports the existence of any portal or doorway to another realm. Yet, why did such a rumor gain so much traction? Its rise suggests a tension between cutting-edge science and the stories people tell to make sense of the unknown. A key figure disrupting this balance is Max Laughlin, a 13-year-old physics enthusiast who has studied the collider's work in detail. His grasp of particle physics and the collider's experiments rapidly earned respect from scientists and public figures alike. Max first encountered the portal rumor on social media and immediately began fact-checking. His findings challenged the viral narratives and sought to ground the discussion in verifiable science. Max's expertise comes from a genuine passion for discovery. He built his own cloud chamber to visualize particle paths and won awards for his scientific projects. When producers invited him to join Joe Rogan's podcast, it was clear they wanted someone who could translate complex science for a broad audience. His youthful clarity brought an unusual lens to a story full of hype and confusion. As the conversation deepened, Max laid out what the collider actually does, dismantling myths step by step. He pointed out that all CERN results, including any anomalies, are published openly online for anyone to review. No secret experiments involving portals exist in official records, and independent researchers globally analyze the data daily. Max emphasized that extraordinary claims demand extraordinary evidence, which has not appeared. Still, there was a subtlety beneath Max's calm explanations, a hint that he had noticed something deeper, something that goes beyond the surface of rumors or standard physics interpretations. This mystery keeps the story from settling simply as a debunked conspiracy. It suggests that real scientific frontiers remain open, waiting for a clearer understanding. If the portal story is largely a product of misunderstanding and exaggeration, what then is happening inside the collider tunnels? To answer this, it is important to grasp how the collider itself works and what it really reveals about the fabric of reality, how the collider actually works. The Large Hadron Collider is an engineering marvel designed to probe the smallest building blocks of matter. It rests underground, a continuous loop stretching 27 kilometers beneath fields near Geneva. The tunnel hosts two beams of protons traveling in opposite directions, guided by superconducting magnets chilled to temperatures colder than deep space, nearly negative 271 degrees Celsius. The magnets guide protons through the circular track, while radio frequency waves with high strength boost their velocity to near light speed. Sensors track their exact position more than 1,000 times every second to maintain tight beam focus. The The high-energy crashes create powerful detectors that capture the results when particles reach their designated collision points. The collisions release energy levels that match the universe's state during the first milliseconds after the Big Bang. The explosive encounters produce a shower of new particles, sometimes rare and short-lived. The massive detector systems, ATLAS and CMS, which contain multiple tons of metal and silicon materials, achieve their system performance through precise recording of the particle cascade. The tiny chips measure mass and charge and speed, which enables the chips to transform signals into data streams that physicists worldwide can access. The entire process undergoes examination by engineer and technician teams who execute active supervision at all times. Control rooms above ground are filled with screens and consoles where operators manage beam injections, magnet currents, and safety systems. The system uses thousands of computers to process large amounts of data, which it sends through a worldwide network to data centers. Daily analysis of these results occurs by researchers from more than 100 countries who search for patterns and anomalies. The primary scientific aims include studying the Higgs boson, the particle that gives mass to others, and searching for elusive dark matter candidates believed to shape galaxies. The collider investigates how gravity works at extremely small distances while examining the possibility of existing additional dimensions beyond the 3 dimensions we know. Physicists search for patterns of missing energy that might indicate the existence of particles that move toward hidden regions. Researchers have failed to find or create any experimental evidence that could show the existence of portals leading to other dimensions. All scientists can access complete details of every experimental run, which includes information about all particle collisions and all collected data. CERN operates its collider upgrades to achieve higher energy levels while increasing collision rates, which will help scientists find rare events and improve their scientific knowledge. The technical realities of the situation stand in complete opposition to the rumors that continue to spread. Most people lack the ability to comprehend technical information, so they rely on sensational stories to explain missing information. An innocent observation developed into a widely accepted rumor about secret portals, which spread among people. The answer lies tangled in a web of online misinformation and viral storytelling. The stories that capture the imagination often begin with something quite ordinary, but they grow by tapping into our fascination with mystery and the unknown. From here, the conversation shifts naturally into how the portal myth spread so widely, crossing into realms far from stringent scientific verification, tracking the viral spread of portal stories. The tale of a supposed CERN portal did not start within physics journals or official announcements. Instead, it began with an obscure internet post where someone described fleeting strange lights near one of the collider's tunnels late at night. This casual remark, likely innocent, caught the attention of readers hunting for unusual science news. The satirical website created an eye-catching headline about CERN opening another world portal based on that short post. The readers who first read the material as a joke did not understand its actual basis because they interpreted it as a genuine news report. Social media platforms experienced rapid content spread because people shared headlines that created excitement while they did not yet know the actual facts. YouTube channels and online forums picked up the idea, often layering their own dramatic narration and stock footage to paint a picture of secret experiments and government cover-ups. The posts promised to provide insider footage and leaked documents, but they delivered no new evidence. The researchers used different words to present the same satirical content, which resulted in a falsehood that gained more visibility. Search engines amplified the problem by returning these sensational articles near the top of their results for phrases like CERN portal. The first sources that people who lacked knowledge about collider science encountered were misleading sources, which they accepted as trustworthy information. The content reached millions of viewers within hours because it presented information that mixed real events with fictional elements without showing any explicit warning. Conspiracy websites further complicated the narrative by linking the portal story to ancient European myths and clandestine military projects. These claims relied on untraceable quotes and second-hand sources, lacking any verifiable proof. No CERN scientist or engineer reportedly supported these ideas on record, making them purely speculative. The researchers conducted their investigation by studying CERN's press releases and public data archives. The research found no signs of an experimental portal. CERN publishes all its technical notes and results, but none of these documents contain information about space tearing or gateway opening. Max Laughlin discovered the narrative during a chat with a group, and he chose to do research on it. He found CERN's official statements, which denied the existence of experiments, and he found the scientific information that explained why proton collisions cannot create space-time destruction. Max prepared the written materials, which explained the actual operation of the collider, before he appeared on Joe Rogan's podcast. Joe Rogan and Max demonstrated how the rumor started as a simple observation before it developed into a popular internet trend. The researchers played the original posts, and they matched them against the official documents to show how social media and satire can create false impressions of reality. The investigation showed different levels of false information, but it failed to reveal what information researchers currently lack. The quest to understand these deeper layers now draws us toward new theories and experiments that stretch far beyond the collider tunnels and viral rumors alike. Scientific search for extra dimensions. The idea of dimensions beyond the familiar three has intrigued physicists for over a century. Early in the 20th century, mathematicians and scientists began to imagine that space might extend into hidden directions, too small or subtle for everyday experience. These extra dimensions could hold the key to uniting gravity with other fundamental forces, offering a more complete picture of how the universe works. Modern theories, like string theory, build on this by suggesting that particles are not point-like dots, but tiny vibrating strings. These strings vibrate in multiple spatial dimensions, sometimes as many as 10 or 11. The shape and size of these hidden dimensions influence the properties of particles and forces we observe, making them crucial to understanding physics at its deepest level. The process of testing extra dimensions creates extremely difficult problems to solve. The dimensions that scientists seek to find exist at extremely small dimensions that reach 1/1000th of a meter, making them almost impossible to detect. Scientists search for hidden particle evidence through indirect methods, which track energy loss from particle collisions, to find evidence of particles moving into hidden dimensions. Scientists at the Large Hadron Collider perform their experiments by examining every aspect of proton collision experiments to find evidence for these theories. Research groups create experimental setups that use metal plates placed at short distances for gravitational measurement. The research team uses metal plates, which they position at millimeter distances, to measure disturbances from Einstein's theoretical predictions. The research experiments so far have discovered no unexpected results, which eliminates large extra dimension possibilities at that specific distance scale. Astronomical research provides additional proof through its findings that cosmic rays and black hole mergers show no signs of concealed dimensions influencing universal operations. The gravitational wave detectors, LIGO and Virgo, detect the gravitational waves that emerge from black hole collisions. The waves that travel through spacetime will display their actual behavior because extra dimensions create dimensional distortions. The scientists have detected signals that match standard physics. They can use this information to create more precise boundaries that define the locations of concealed spaces. The search continues with full dedication, although no direct evidence has been found. The quest for extra dimensions holds profound implications beyond physics. The existence of such dimensions would shape our understanding of dark matter and the entire universe. Some models even suggest that particles associated with dark matter could be manifestations of these hidden spaces, offering a tantalizing link between two of the greatest mysteries in modern science. The current mathematical methods and experimental details remain too complex for scientists to reach definite proof about the research area. Physicists maintain their cautious optimism as they enhance research methods and broaden their investigation areas. The research team uses null results to develop future research methods, While their findings help them determine upcoming research areas, they maintain their hope for breakthrough discoveries that will change our fundamental understanding of reality. Sometimes the universe hides its secrets not by locking them away, but by weaving them into patterns we have yet to recognize. The role of dark matter. Dark matter is one of the most elusive puzzles confronting modern physics and astronomy. Comprising roughly 85% of the total matter in the universe, it exerts gravitational pull, yet does not emit, absorb, or reflect light. Its invisible nature means we can only infer it from its effects on galaxies and cosmic structures, making it a central focus of numerous experiments worldwide. Scientists attempt to detect dark matter particles in highly sensitive underground detectors filled with materials like liquid xenon or argon. When a dark matter particle collides with an atomic nucleus, it may create tiny flashes of light or electrical signals. While experiments such as Xenon in Italy and Lux Zeppelin in the United States have advanced the sensitivity of these searches, no conclusive dark matter interaction has been observed so far. Complementing these direct searches, particle colliders like the Large Hadron Collider hope to produce dark matter particles in high-energy collisions. If these particles appear alongside familiar ones, they could reveal new physics beyond the standard model. However, so far, no such events have surfaced in the collider's extensive datasets, placing stricter limits on theoretical models. The second mystery involves neutrinos, which are mysterious particles that only make weak connections with matter and travel through common materials without interruption. The Super Kamiokande facility in Japan, together with Antarctica's Ice Cube facility, has demonstrated that neutrinos change between various forms during their flight. Scientists remain uncertain about the mechanism that creates tiny neutrino masses because this discovery won a Nobel Prize. The Deep Underground Neutrino Experiment, together with its new facilities, will send neutrino beams across extended distances to achieve more accurate studies of neutrino behavior. The process of understanding neutrinos now enables scientists to discover information about early universe conditions, together with the reasons that led to today's matter dominance over antimatter. Some theories propose a connection between dark matter and extra dimensions, which suggests that dark matter particles can be found in these concealed dimensions. Although no proof exists to support this theory, various scientific questions seem to share common connections with open physics questions. The dark matter investigation aims to find more than just one cosmic element, because it seeks to discover unknown types of matter and fundamental forces. The world of quantum physics brings forth extraordinary phenomena while presenting complex challenges to researchers. Research into particles' dual nature establishes whether particles behave as waves or particles because this phenomenon demonstrates that measurement creates reality. The double-slit experiment, together with classical space and causality concepts, proves that the universe becomes more bizarre at its smallest dimensions than it appears to be. As one discovery after another peels back layers of the unknown, these intertwined mysteries signal that the universe holds deeper truths still beyond our grasp. What Max Laughlin revealed. Max Laughlin's insights go beyond simply debunking viral rumors. They open a window into the subtle and profound mysteries that physicists continue to explore. During his conversation with Joe Rogan, Max described how collisions inside the Large Hadron Collider recreate conditions from just after the Big Bang, producing sprays of particles that offer clues about the building blocks of everything around us. He emphasized that studying this debris tests theories about the fundamental forces shaping reality. The concept of parallel worlds attracted Max's notice because some scientific models demonstrate that different realities exist in simultaneous existence, while each reality operates under its own distinct set of laws. The researcher identified the Large Hadron Collider as an exceptional facility that provides enough energy to enable particles to transition between alternate dimensions, but he accurately stated that all gathered evidence corresponds with scientific predictions. Thus, no proof exists that particles are moving into other dimensions. Max explained the double-slit experiment, which shows how particles create wave patterns that change when someone watches them. The experiment demonstrates that reality exists at tiny dimensions which scientists can measure, while the study shows how observers affect things in the universe. Max described matter as not solid, but rather energy vibrating at specific frequencies. He linked this to the discovery of the Higgs boson in 2012, which explained why some particles have mass while others do not. The collider confirmed this by tracking how the Higgs decays into familiar particles, which showed how vibrations and fields determine the properties of matter. The universe contains more invisible matter than visible atomic matter, according to Max, who studied dark matter. The substance exists because it does not reflect light, and it does not show any connection to known forces that exist in the universe. He mentioned that scientists at underground facilities conduct research to identify rare instances when dark matter particles collide with atomic nuclei. Max used data and experimental outcomes to show that CERN and other laboratories currently establish the boundaries that existing scientific theories can reach. His explanation of modern physics showed various aspects of the field through his description of particle showers from large detectors and through his explanation of underground lab measurements, which scientists conduct in their quiet spaces. From debunking viral portal myths to revealing profound mysteries, this journey shows how curiosity and careful science go hand in hand. The world beneath CERN's tunnels may not hide gateways to other dimensions, but it does challenge us to keep searching for answers that could redefine reality. If you found this exploration fascinating, be sure to like and subscribe for more deep dives into the wonders of science.